Hello, picking up right where we left off. We just finished off using just some simple trig. We knew that the cosine of this had to be equal to the 100, right? Because this is pulling away and this is pulling, and Bar is being pushed away by Alejandro, and Caroline is pulling him back. So if he's going away with 100 pounds of force, Caroline's got to pull him back with 100 pounds of force in the x direction. So that means that 100 was equal to the cosine times this overall force, and then we knew the cosine, and then we divided by that to get the overall force. So review that in the last video. That's how we solved that one. So what force do we have left? We have the force BD. And this is a bit of a tricky one, because it's not necessarily what you would immediately think it is. That is, the problem isn't quite as simple as it may seem right away. It doesn't, or at least it's maybe the best way to say it is misleading. Because what your first instinct might be to do would be to say, okay, this 80 pounds has to be supported by this and this. You might want to say that both of these beams, like the beams here, this makes it look like both of these are pushing up to resist that 80 pounds. But that's actually not true. Remember, in the last video, we said that this could have been a string or something, right? Or a cable. So that's not going to support any weight. In fact, that's going to take away. That's going to be pulling. You figure some part of this is going to be pulling. Some part of this is going to be pulling down, right? Or rather, this part of it is going to be pulling down on this B, right? So that's going to actually be increasing the weight there. So what we get is we get that this weight right here, 80, plus, well, how much is this force pulling downwards? Because remember, this is a tensive force. It's pulling down on B. So how much is it pulling downwards? Well, that's just our cosine. Our sine, our height of the triangle, times the 167, right? That's just some of our basic trig stuff. Hopefully by now you're kind of getting used to seeing some of that. So that's equal to 80 plus 167 times, well, we know that sine t is 0.8, right? Because we figured that out, because this was 4 and this was 5. We just used the ratios, opposite over hypotenuse. And that's equal to 80 plus, what's 167 times 8? Anyone know? Eric, do you know that one? No? Okay. 167 times 8, we get 1336. I'm sorry, I did times 0.8. I should have done times 0.8, so I could just move the decimal, but whatever. 167 times 0.8. There we go. We get 133.6. Which, I'm trying to think, I'm trying to figure out whether or not I want to keep that decimal there. Nah, I guess we'll just kind of leave it off. So we'll just leave it at 133. That's interesting that it's 0.6 though. But, so we got 80 plus 133, that gives us 213. And what is that? Well, that's if we've got this pulling down, right? This BC right here, if that's pulling down, and then also this force is pushing down, then the total is going to be just the sum of those two. And the sum of 80 plus the y component of this, we got to be 213. So here we've just figured out that BD is equal to 213. Whoops. There we go. So BD right here is equal to 213. And these are all in pounds, right, because they're all forces. But I'm just not putting that there, because it could also be newtons, and the problem would be identical. Okay, so there's not, here, let me move this stuff. Remember, this was just, I drew in there, so I'm just going to take that out, because that was just to exemplify something. this arrow right there. Oh, I took off part of 80. Oh well, 80 can live with it. It doesn't need a chin. So we're going to take that, and then we're going to make a copy of it and flip it. We're used to this, kind of. So then, if this is pushing down or getting pulled down, this one's pushing back up. It's resisting that motion. And we can kind of take all this, take this 80, we don't need that anymore, right? Because now we know that this force right here is just equal to our 213. That's what we just solved for. That's what we just spent the whole video solving for. So that's our 213. And what would you do? What would happen if you put a soda can here? Well, it would get crushed. So crushed, that's compressive. So that's a compressive force. Now, what other forces are going on here? It's very easy to look at this and say, okay, I'm done with this problem, but not quite. Because think about all the things that you're testing. You have to know that this AC... Oh, wait, hold on. Let me draw the big red line to make us feel proud of ourselves. Yay, accomplishments. Okay, now, we've gotten most of this done, right? We've got each of these with the red lines, so what are we missing? Well, think about it. What are we testing? What does each of these things have to be able to do? Well, AC has to be able to hold 60 pounds, AB has to be able to hold 100 pounds, CB has to be able to hold 67 pounds, and BD has to be able to hold 213 pounds. What other forces do we need? Well, there's actually 3. 2 of them are kind of obvious, the ones that we put right here, and one of them is not so obvious, so we'll do the one that's not so obvious at the very end. What we need is, we need this force, right, this force that D is exerting on the ground, and then we need the force that C is exerting on the ground. Mind you, C could be pulling upwards, and actually it's going to turn out that it is pulling upwards, I think. So it's going to be pulling upwards. So it's going to be like C pulling up on that little on whatever it is that's holding it into the ground. We'll get to that in a sec. So how much is D pushing into the ground? Well, that's actually a really, really easy question to answer, because you figure B is pushing into D with 213 pounds of force, so D is pushing downwards with 213 pounds of force, because there's no additional anything acting on it, right? So that's the only force pushing it down, so it's going to push down with 213 pounds. And of course, we're ignoring all the weights of any wood and any pins going on here. So, actually, like that. So we can say that these are the same, right? That's equal to that. Okay, and now this one's a little bit tougher. What's the force between C and the ground? Or between this yellow bit and the ground? Well, it's going to be kind of like 2 pieces, right? This is pushing up. Or rather, oh, no, I'm sorry. A is pushing down on C, right? A is, let me delete this junk. A is pushing down on C with 60 pounds of force, right? That's negative 60, because we figure it's down. And then, what else is there? Well, bar is pulling Caroline back up. Or this B is pulling C back up. So how much is it pulling up? Well, that's going to be just kind of like this vertical piece, right? Well, guess what that is? It's actually what we just solved for. That's our 213, but I'll go through it again. It's plus our 167 sine of t. And the 167, because it's the magnitude times the percentage of it that's in the y direction, right? That's what sine of t is, the percentage that's in the y direction. That's equal to negative 60 plus well, 167 times, well, sine of t, right, sine of t is 0.8, so times 0.8. And that gives us 133.6. So 133. Remember, that's just what we used the last time, the 133 there. So that one's pulling up with 133. So the net force is the same as saying 133 minus 60. Hopefully that should be really obvious, because you should all be able to see that negative 60 plus 133 was 133 minus 60, but I hope that's clear. So what do you end up with? You end up getting, what is that? Is that 63? Anyone confirm that? Yes or no? No, that's 73. Haha. That's why I don't listen to you. I don't know what I'm saying. Sorry, I'm tired. So we just found out that 73 should be how much this C is kind of pulling upwards on that joint. So all of these, I guess you could say, are kind of like, well, just the overall C is pulling upwards on the joint, and the joint is pulling downwards with 73 pounds. It's the same. So the force, regardless of which end you're looking at, is the same, because it's acting in both directions. Yay, Newton's law. For every action, there's an equal and opposite reaction. So that's the 73 right there. I'm hoping I didn't make some sort of stupid calculation error that suddenly screws everything up, because I would be likely to do that. But I actually haven't looked at the answers yet, so I might have done this problem completely wrong. But if you're watching this video, then that means that I didn't do it completely wrong, because then I wouldn't have uploaded it. So we'll see whether or not I end up uploading all these videos, actually, because I probably should have checked the answer first, but we'll get to that. Okay, so there's one thing left. Think about what's happening. B is getting pushed away, right? So it's pulling back on Caroline. And Caroline is being pulled this way. She's being pulled in the x direction. So what's keeping her from going in the x direction? Well, there's got to be some force pulling her back. And that's the one that is not too obvious. So if you guess that, good job. You understand this. So we need to find that force. And that force is going to be pretty easy, because all we really need to do is figure out how much bar is pulling in this direction. So that's going to be, oops, it's like this bigger. That's just going to be 167 times the cosine of t, right? Because that's this horizontal part. This is the cosine times this. Now it's going to be equal to, well, cosine of t is 0.6, so handy dandy calculator, 167 times 0.6, we get about 100, right? So that's equal to 100. And oh, look at that, we ended up getting that it's just about the same as how much B is being pushed. And actually, it is the same. The only reason we got 100.2 here is because Dr. Christo rounds a lot, and so I was rounding like him, and this shows you the kind of error that you can actually get. It's actually noticeable and kind of misleading. So that's equal to 100, and because these are actually the same. So let me draw in actually all the things that we've solved for now. Let me solve for each of these. And now, let me put what our measurements are. This is, what did I say? This was 100. This was our CG, that was 73. And that was our 213. So, what are we going to call this? Let's call this a reaction, some sort of reaction force. So we're going to say the reaction force, NC, is going to be equal to 100. Whoops. I'll only align those. So that's kind of what we just solved for right there. Sorry, I'm a perfectionist. I gotta align these all the right way. So that's the reaction force right there. So that's how much this is pulling back. That's done. We just solved this. Hopefully this helped. I'm almost completely out of time, but I'm going to be making more videos, obviously. So I'll see you then.